Hi everyone, this video is all about standard deviation and variance. And to really understand a lot of other concepts in statistics, you really have to have a firm foundation as to what standard deviation and variance mean. So here we go. So the best way that I found to define what variance means is variance is the average of the sum of the squared deviations from the mean. So what do I mean by this? Well, I'm going to draw a frequency distribution. On the y-axis is I'm going to draw this differently. I'm sorry about that. On the y-axis is one variable. So it could be height, it could be GPA. Let's just do grade. I'm going to do grade and GPA points. So an A is a 4. And then on the x-axis is another variable, hours spent studying. And you can imagine that you could plot these two together. Hours spent studying has some connection to your grade. I'm not going to draw a relationship. You can if you want. But each of these data points is just a plot of X and Y. It's a plot of GPA versus hours spent studying. And you can imagine your data might look like this, where there's no relationship between hours spent studying and GPA. So let's just say I wanted to know the mean of GPA in a system like this. Well, the mean is always a measure of center. So approximately, I'm just going to draw a line through the center of GPA. And this is mu. Sometimes it looks like an M to people, sometimes it looks like a U. As long as you know that this means mean or population mean, you're good. And this line, this red line, might change if there's a relationship. For the purposes of this description, uh, we're going to assume that there's no relationship between these two variables. All right, so the first part is, what is a deviation? Well, the first thing to stress here is that a deviation is not a standard deviation. You need to sort of separate those two concepts in your head because one is not like the other. And so a deviation, I'm going to draw this in blue, is defined by the distance your observation, your outcome has from the mean of what you're observing. And a way to think of it is this. If you are deviant in some way, you are different from the normal, different from the average. And so like someone with a deviant IQ, the average IQ might be 100, and someone with a deviant IQ might be 200. They're different from what the mean is, different from what the average is. Someone with a deviant sort of personality might be so socially extroverted that they are different from what you would normally expect a person to be when they're extroverted. You know, that's the kind of idea that we're going for. So what a deviation from the mean really is the outcome, in this case GPA, you know, on a exam where the average GPA is 78, a 90 is certainly deviant from the average. So like the outcome, exam grade, and it's a distance in blue from the mean. It's a distance measurement. And now distance measurements typically have two components. They have one part, which is the magnitude, the overall chunk or size of the distance. And then they have another part, which is the direction of the distance. So direction can be, are you positive distance away from the mean? It could also be, are you negative distance away from the mean? If you think about this in terms of sort of driving to school, you could be driving towards your school, or you can be driving away from your school. The concept is essentially the same. And so what squaring does is squaring's going to remove this distance. It's going to remove this distance completely. Because what it does is it creates what I would call squared distance. And what squared distance is just the chunk of distance. It's the magnitude of the distance. It's how far you're away. It doesn't care about direction. Are you positive or negative away? It's just how far you're away. And so squaring it does this. A square distance does this because it removes the sign to just give you magnitude of distance. All right, what's next? We have square distance without direction, just magnitude of the distance. Now we have the sum. And all the sum is doing is adding up all these distances. You can sort of assume that each of these black points is a data point and it has its own distance from the mean. So the sum part is just adding it all up. And then finally, it says take the average. And once you take the average, you have what is called variance. So to take the average, if you think about it, when you take an average, let's say you're taking an average of three numbers, 3, 2, 1. What you do is you add up all these numbers, you get a total of 6, and you can see that down here in Excel. And then you divide by the number of observations you have. The number of observations is 3, so you divide and you get 2, which you can see down here in Excel. So essentially what you're doing is the same thing with variance. You're taking this summation of all the individual data points as represented by x sub I from the mean as represented by mu. You can think of this as u if you see this as u in your textbook. Sometimes people do that. But anyway, it's the sum of the outcomes minus the average. So each outcome is minusing from their average to get that deviation. It's the sum of them, and remember, we're squaring it as well. So this black is this part right here. You've taken the outcomes, measured their distance from what is normal, what is the mean, and we've squared them to remove the direction, and we've added them all up together. To take the average, you're going to do the same thing that we did with 3, 2, 1. You're just going to divide by the total number of observations. And now you have variance. And variance is basically in units. The units are in squared distance. And you can interpret it as this is for all the points in your data, what is their average square distance from their mean? Now let's get the standard deviation. And what I want you to see, and actually first, before we do that, let's get the sample variance. We've discussed population variance here. What sample variance really is is you're just changing this bottom denominator figure. And you're changing it to a term called n minus 1. When you change it to n minus 1, that's all you need to do to get sample variance. And it's still the interpretation of you're taking the average. So a sample variance is also the average squared distance your sample has from its mean. This yn minus 1 kind of gets into a whole concept called degrees of freedom. And it also gets into a whole concept of sample versus population. I will have separate videos for that. So don't worry about n minus 1, other than just remembering that's how you get the sample variance, is you just change the n on the bottom to n minus 1. The final part is to talk about standard deviation. And all standard deviation is the root of the variance. So remember I said the units in variance is squared distance? So when you calculate the variance, you're calculating a squared distance. Well, if you take the root of squared distance, which is standard deviation, you take the square root, it will remove that square and just leave you with distance. So what the interpretation of standard deviation is the average distance each observation has from its mean. I wrote that in the Excel. All right, final thing is I really want to show you the progression of this. We start with deviation. And remember, this is a completely different term from standard deviation, so don't relate the two. We do a bunch of things. We most notably take the deviations, we square them, we add them all up, and we take the average, and we get variance. You only get the standard deviation, and I'm just going to type this because it's easier, if you have variance. You need variance first. So standard deviation is sort of an additional part of what variance means. So what we've sought to do in this video is to just break down the concept of standard deviation and variance, so you know exactly what's going on when you hear those terms. And in future videos, we're going to use these concepts to work through and explain some of the more complicated statistics that you'll encounter in your book and in your classes and everything like that. I hope this was helpful. Let me know if you have any questions. Thanks.